Hey, all. Today we're going to continue our discussion on experiments. We're going to add a couple new ideas to what we discussed last time. We already talked about the elements or principles of a well-designed experiment. We always want to have some control. We want to have randomization. We need replication. And in some cases, we will use some blocking. We talked about factors. We talked about treatments. And we talked about laying out diagrams of experiments to keep our thoughts organized. And so today we're going to just talk about a couple different elements that may or may not exist in an experiment. And that first one is blinding. And what blinding helps with in general is sort of the human nature element of experiments. So we tend to have two different types of groups involved in an experiment: those subjects who are actually participating in the experiment, and then people who are measuring the outcomes. And those people who are measuring the outcomes aren't always going to be the researchers. Sometimes those people will be doctors employed by the researchers, or perhaps in this case of our OptiGrow juicy, tasty tomatoes experiment, those people might be farmers or experts in growing tomatoes who will assess the juiciness and tastiness, and then that information will be collected by the researchers. So we have a single blind experiment when one of those two groups doesn't know which treatment they are in. So they don't know what treatment they're getting. Of course, tomatoes are inanimate objects. They are foods. And so they can't really be blind or not blind. But in this case, those people who are tasting, so our taste testers, if they don't know what level of fertilizer the plant's got, then they can taste the tomatoes, tell us about their juiciness, tell us about their tastiness, whatever scale that is that they are going to be judging those on. And they won't have any bias based on knowing that the plant's got the OptiGrow, or they got half the OptiGrow, or they got none. We do have this sort of human nature thing where we might think that the tomato should be juicier because we know it used the special fertilizer, and so that could bias our results. And so it would be a good idea for these people to do a blind taste testing, and then of course the researchers will know which tomatoes they're eating, so that when they collect that data, they know the ratings of the specific treatment groups. A double-blind experiment would be that both groups don't know the treatment. So in a single blind, one group doesn't know. In a double blind, both groups don't know the treatment. If you can, a double blind experiment is good. Here we can't do double blind experiment because the tomatoes will never know which fertilizer they get. Often, in order to create blinding, we use these things called placebos. It's often used with medications, where when we're testing a new medication, we'll want to give one of the groups, which we'd call a control group, we would want to give them something that looks like the medication, so they don't know if they're actually getting a medication or not. So the body will do interesting things if you think that you are being treated for something, then your mind can sort of play tricks on you. So, for example, like if one group was given alcohol and one group was given something non-alcoholic that looked the same, they might start feeling some sort of effect of alcohol if they think they are actually drinking alcohol. So sometimes it's necessary to have a group take a medication or take a placebo so they are blind to what treatment they are part of. So when possible, we would like to double blind, and we would like to use placebos to control. We always want to be able to compare our results, and of course, randomization is always necessary. We did discuss multiple factors a little bit last time. I do believe we had some experiments that required multiple factors, but let's have a chat about it again. Here we have, again, our tomatoes, but now we are concerned with the water. And so more than just the fertilizer, we want to control the water. So now we are talking about two different factors. We have fertilizer at 3 levels. We had the full dose, half dose, and we had none. And now we will have a second factor of water, and we are going to give either water to some or no water. So 2 levels. And when we're coming up with our treatments, we are going to use the fact that we have 3 levels of one factor and 2 levels of the other factor to determine that we have 6 treatments. So we are going to have full dose and water. We're going to have full dose, no water, half dose with water, half dose with no water, no fertilizer with water, and then no fertilizer with no water. So we'll have 6 different treatment groups, combining the different levels of both treatments so that we can see, you know, is it the water? Is it the fertilizer? Is it a combination of the two that is creating these tastier plants? So the last thing we need to discuss and be mindful of when running an experiment is a confounding variable. And so back a long while ago when we talked about 2 quantitative variables and we did linear regression, we talked about this thing called a lurking variable. And that was something that was connected to both variables that we were analyzing that could have an effect on the relationship between those 2 variables if we are not careful. So we talked about air conditioning sales and ice cream sales both increase as the temperature increases. So we could potentially think we have some relationship between air conditioning sales and ice cream sales. However, that lurking variable of temperature that has a relationship with both of those things is creating this relationship that really doesn't exist. That's similar to this, but different a little bit. So let's pretend that I'm teaching this class just for 1 semester. So we meet each day for 1 semester. And so I'm going to teach this class in the fall and in the spring. And I want to use 2 different teaching methods in the fall and in the spring. So let's say in the fall, I do a traditional teaching method. And then in the spring, I do the method I'm using right now where we create videos, a sort of blended learning type method. And I want to get an idea of the differences between those 2 things and see if one works better than the other. So there are some things I would need to control for that I could control for. I could control for what time of day, so we could set it up so that I teach both classes during 7th block. So the time of day won't be affecting those students. I would teach both classes, so the instructor is not going to be influencing those students. But there are some things that I wouldn't be able to control for, and that big thing that I wouldn't be able to control for here is the time of year. or we could say the season of the year. Sometimes what time of year it is affects people's moods, it affects people's ambitions, it affects their energy. And so some people do better during the spring than they do in the fall, or vice versa. And so that is not something I would be able to uh, control for. It would be considered a confounding variable, and something we definitely have to keep in mind if this is something that we would want to study. We can control for the time of day we teach, we can control for who teaches, we can control for the number of students in a class, we can make sure both the same number of students. There might be a qualification on uh, your grades or your GPA to be in the class so that we have students at the same ability level. But this type of thing we would not be able to control for. If I tried to teach the same class at the same time of year, then I wouldn't be able to control for the time of day, which would then create that as a confounding variable. So something to think about when it comes to experimental design. So I want you to pause here and give this one a try, then come back and check your answers. So go ahead and check your answers here. So if we were to have this study be single blind, of course, the people who are eating dessert and not eating dessert and exercising and not exercising, they know which treatment group they're in. So they will not be blind in this scenario. But the people assessing their sleep quality, it's possible to make sure that they don't know which group these participants were in. And so they'll just assess their sleep objectively, and then the researchers can compare the sleep quality based on the treatment groups. We wouldn't want a placebo here. It would be difficult to do any sort of placebo when it comes to exercise or eating dessert. And I put a couple confounding variables, something that might detract from your sleep would be nighttime technology use. So unless they were controlling for that, that could potentially lead to some confounding. Also, people who already have previous exercise routines or regimens might, an increased exercise might not be something that actually helps their sleep. And I would be interested in if anybody came up with anything different that they'd want to share in class. Feel free to do that. So, of course, I do have some practice for you. Please answer these questions. If you need any help while you're working through them, please do feel free to work together or ask me for help. I'd love to have a chat about it. Other than that, take your time and good luck.